All right, so in your Chemistry 30 review assignment number 1, we're going to go over number 6C in this video. I will show you here 6A. We did this yesterday, okay? So if we're calculating number of moles of SO2 in a certain number of grams of SO2, then what we do is we convert grams to moles. And I think you had asked me about this little chart here again. So real quickly again, this little chart here is the sort of the general instructions for converting mass to moles, moles to representative particles, and then back and forth. So if you have this chart memorized or on your reference sheet and you see you're given mass, you're asked for moles, that means you kind of start up here in this area and you have to follow the arrow down to convert to moles. And so what's the connection between mass and moles is grams per mole. So we take this number of grams and divide it by the grams per mole of SO2, okay? And you get this for an answer there. For B, we did B as well, very similar, okay? You've got the number of grams, and here we didn't use the chart, we used unit analysis. And unit analysis states that if you multiply by some kind of conversion factor and arrange that conversion factor so that units cancel out and you're left with the units that you want in the question, then you can simply just do a series of multiplications to get rid of the units that you don't want. So grams converting to moles will multiply by moles per gram. And in this case, O2 has 31.9988 grams in 1 mole, and so here's our answer for B. The question today was about C, so let's take a look at C here now. And C is going to have a little bit more calculation, I guess, because we just have a bigger compound here, so there's more elements to add up and stuff like that. But really, it's a mass, and I'm converting this to moles, so it's really the same sort of thing. If you didn't quite get this one correct or got stuck, it may have been in calculating the grams per mole, maybe. So, grams per mole. So you want to get your periodic table out so you can reference that. Some of these you should know. You probably have memorized the mass for some of these elements already. And if not, you should memorize hydrogen for sure. Oxygen, you should know for sure. Probably nitrogen, that would be one to put on your list. Chromium doesn't come up very often, so I wouldn't expect you to memorize that one. But let's find out the grams per mole here of NH42 Cr2O7. This would be ammonium dichromate. Ammonium dichromate is the name of this. Ammonium is this ion, dichromate is this ion. Slap them together. Okay. So we've got one nitrogen. So nitrogen is what? 14.0067? 4? Good. Sure. We'll go to 4. So that's one nitrogen, or how many nitrogens do I have in this compound? 2. Yeah, 2. So we got to be careful there. It looks like we just have one, but we actually have 2 of these ions. So this has got to be times 2. Okay. Plus, how many hydrogens do we have? 8. We have 8 hydrogens. 1.00794. Okay, good. Chromiums. So you look at chromium, that's 51.9961. And that's times 2. And then we have 7 oxygens. 7 times 15.9994. Okay. So you do all that in your calculator. I'll get my calculator going here. So let's just see here. All right. Turn it on. Clear that screen. So I've got 2 times 14.00674 plus 8 times, I would encourage you to use your brackets there. Just makes things a little bit easier. Plus 2 times 51.9961. So make sure all these are hitting all these buttons correctly. Okay, bracket. Plus 7 times our mass for oxygen. Okay, so just double check that. 2 times 14, 8 times 1, 2 times 51. Okay, hit enter. 252.065, did everybody get that? 252.065. Now that would be grams per mole of this ammonium dichromate. If I have 250 grams, I almost have exactly 1 mole, don't I? So I actually have a little bit more than 1 mole. So how are we going to do this? Well, if you refer to your chart, you do this grams divided by the grams per mole. Or unit analysis says, let's start with what we're given, and let's multiply by some conversion factor that will eliminate the units that I don't want. And I'm going to end up with the units that I want here, right? So unit analysis is great too. 1 mole is 252.065 grams. And you see that you do end up dividing mass by the value for grams per mole. See? On top and on bottom. And so there you go. A little calculator trick there. If you're given this bottom number, okay, couple things you could do. You could do 250 divided by answer. Or this little button here, x to the negative 1, if you just do that, that takes 1 over your answer. And so I just did that, and now you can multiply by 250. So a couple of calculator tricks there. 250. Okay? So you should get, so what did I say, more than a mole? We have 250. Apologize. I think I said we should have a little bit more than 1 mole. We have a little bit less because 250 is just a little bit less than 252. My mistake. So 0.9918. All right. So 0.9918 moles of ammonium chromate. I won't make you write that down, but that's your answer for C. Let's just check that. Okay, so that's the answer I've listed there. So here's your solutions for 3 through 6, and also 7 and 8. On the website, www.mrmathwell.com. I believe I do have a document with the answers to these reviews, selected answers. So you can always go on the website to check that out. Okay. Does that clear up questions for 6 now? Before we move on.
What is the difference between a mole and a molecule?
Oh.
They just sound so similar.
Yes, very good question. That question was, what is the difference between a mole and a molecule? Okay, very important distinction. Let's talk about that. A molecule would be the actual literal, this atom bonded with this atom, bonded with this atom. One molecule is like the tiniest little, piece of that substance, okay? One molecule. So an H2O molecule is actually 2 hydrogen atoms and 1 oxygen atom bonded together. That's a molecule. A mole is a collection of those molecules, or whatever, atoms, ions, molecules. It's 6.02 times 10 to the 23rd of them. So it's a whole massive amount of them, making 1 mole. And the reason why that number is so high is because this is the special number that connects the numbers on the periodic table, the atomic mass, so these little numbers here underneath the symbols, that number right there equals the mass in grams of 1 mole of these elements. So a mole is 6.02 times 10 to the 23rd molecules of something, or particles of something. Okay? So 1 is a whole big number of them, and 1 is just one little particle. Okay, any other questions?